In this section, we're going to focus on form validation. Form validation is the process of checking if the input from the user is in the correct format. For example, you may have a field for an age. You can use validation to check if the input meets a set of criteria. You'll want to check if the value is numeric. It's also common to check if the number is between a minimum and maximum range. Validation plays a role in saving resources. Traditionally, form validation is performed on the server. After a user fills out a form, the data is transmitted to a server. Before the server inserts the form data into the database, it will validate the input. In addition, the server may sanitize the data to prevent malicious code from executing. Performing validation on user-submitted data is a crucial step to take. You don't want to insert improper data into the database. There is a downside for performing validation on the server. If the user makes a mistake, they'll have to wait for a response from the server to notify them of their mistake. In this day and age, most users have the expectation of immediate feedback. On top of this, servers must allocate resources to process the request. Performing validation on the server is costly and slow. JavaScript has come a long way. It's possible to perform form validation on the client. It allows for feedback to be immediate. Since validation is performed on the browser, you save a lot on resources. To be clear, validation should always be performed on the server regardless if we do it on the client. It may seem redundant. However, the purpose of form validation on the client is to improve user experience and save resources. It is still possible to bypass validation if the user is smart enough. In fact, form validation was one of the reasons why JavaScript was introduced as a language. One of the original purposes of JavaScript was to perform form validation. The user would receive immediate feedback if they made a mistake. The server wouldn't have to allocate resources since a request was never made in the first place. Even though the internet is faster than ever and servers are more powerful than before, it's still a good idea to perform form validation. It reduces the number of requests made to a server. In the end, it's up to you. Performing client-side form validation is optional. Alright, if you're convinced, then let's take a look at how we can perform form validation in Vue. By default, Vue has minimal support for validation. Technically, we can perform validation without a library or third-party package. The process is straightforward. Events are used to listen for form submissions and user input. Before a form is submitted, conditions are performed against the user's input. An error will get outputted if a condition fails. It's perfectly fine to use Vue on its own for form validation. However, there is a problem. You may need to perform validation on multiple forms. This increases the likelihood of repetitive code. In this instance, you may want to create a few functions that will help you manage some of the more common and basic validation checks. You could create this on your own, or you could use a third-party library. For this course, we'll be using a third-party library. Another benefit of using a third-party library is that they're usually tested to work on all browsers and are kept up to date. Vue doesn't provide any official libraries for form validation. Instead, it recommends two options, which are Vuelidate and vValidate. In the resource section of this lecture, I provide a link to both libraries. Both are excellent libraries. Choosing one boils down to preference. For this course, we'll be using vValidate. It's more frequently updated and is very flexible. Let's begin the installation. Switch over to the command line. If you have the server running, turn it off. Packages must be installed while the server isn't running. After doing so, run the following command: npm ivvalidate. We've successfully installed the library. We'll continue in the next lecture. In this lecture, the next step is to register the validation library we installed in our project. There are two ways we can approach this. We can register it locally or globally. The approach you'll want to use depends on how often you plan on using validation. If you're going to use validation for one or two forms, registering it locally is the way to go. However, we'll be using it more than once. Registering it globally is the way to go. One problem with this approach is how much configuration we'll have to do. vValidate is a very powerful library because validation varies from form to form. It's able to accommodate most scenarios. We'll be writing a lot of code for configuring this library. We don't want to clutter the code inside the main.js file with too much configuration. We want to keep it as light as possible. We'll outsource the configuration in a separate file by creating a custom plugin. Up until now, we've been installing libraries that come bundled as plugins. We registered plugins by using the use function on the Vue instance. We can create a custom plugin to extend Vue. Let's try creating a custom one for registering vValidate. Inside the source directory, we'll create a folder called includes. This directory is where we'll define our custom plugins. In some projects, there are developers who will use the name plugins for their directory. We're using a different naming convention because we'll be placing non-plugin files in this directory. If you want, feel free to further organize the project by creating a directory called plugins exclusively for plugin files. We will keep it simple by having one directory for everything. Inside this directory, we'll create a file called validation.js. Inside the file, we'll create a plugin by exporting an object under the default namespace. The object will have one method called install. Plugins are objects with a method called install. Vue will call the install method when we register it. Let's do that next. In the main.js file, we'll import the plugin under the name vValidate plugin. Next, we'll call the use function below the other use functions. We'll pass in our custom plugin. Before Vue mounts our application, it'll run the install method in our plugin. Inside the install method, we're allowed to do anything we want. We can register components, directives, etc. There are two arguments we can accept in the install method. They're the app and options arguments. The app argument is a reference to the Vue application. We have access to the same methods and properties we would normally encounter on the Vue instance. The options argument is additional data passed from the Vue instance to the plugin. Back in the main.js file, the use function has a second optional parameter. We can pass in an object that we would like to provide the plugin. For example, I'll pass in an object with a random property. The object will be the value for the second argument in the install function. Typically, developers use this to allow other developers to configure how the plugin will function. It varies from plugin to plugin. So far, we haven't had to configure any of the plugins we've installed. We won't need this parameter for our project. This custom plugin is exclusively for this project. We'll be removing its use in both files. Back to the task at hand. In the validation file, we're going to register two components. First, we'll import them. At the top of the file, we'll import two components from the vValidate package. They're the form and field components. The components we're importing were specifically designed to help us validate a form. We'll learn how they'll help us in upcoming lectures. We're going to register the components globally because we'll be performing validation on various forms in our app. There's one problem with the name of the components. There's already an element with the name form. We don't want to cause conflicting issues in our app. We'll rename the components in the import statement by using the as keyword. We'll rename the form component to vForm. The field component will be renamed to vField. Inside the install method, we'll register both components with the component function. We're finished. Let's test if everything is working. If you haven't already, turn on the server. View the app in the browser. Everything should still be working. There shouldn't be any errors in the console. Congrats! We've successfully installed the vValidate library. We can proceed with form validation. vValidate is ready to go. It's time to validate the input fields. In this lecture, we're going to start using the components we registered previously. I'm using the modal we've prepared in the previous section. There are two forms, which are the login and registration forms. We're going to begin with validating the registration form. The form will have additional fields that normally wouldn't appear on a registration form. At the very least, you'll usually ask for the email, username, and password. I decided to add additional fields for demonstration purposes. It'll give us the opportunity to look at how we would validate various types of input fields. Now that we have an overview of things, let's begin. Switch over to the editor. Inside the authentication component, search for the registration form. There's a comment above the form that says registration form. If you want, you can fold the login form to better focus on the registration form. We won't be dealing with the login form for a while. The very first field in the form is for the name. It's a text field with no unique attributes. The objective of this lecture is to validate this field. We're going to use one rule. We want to make the name a required field. There's already an HTML5 attribute called required that prevents a form from being submitted if a field is left empty. That's an option, but we won't be using it. We'll want to use vValidate because it'll give us better control over the error. The first step is to replace the form element for the registration form with the vForm component. The job of the vForm component is to organize a set of validations in a form. We'll be able to globally control the form with this component. It'll help us verify if every input field in the form is valid. The form component will generate a tag that will wrap the component. By default, it'll use a form tag. This is why we can safely replace the form element with the vForm component. The thing we want to validate specifically is the value from the input field. By default, vValidate doesn't perform validation on any of the elements placed inside it. We need to tell it which inputs should be validated explicitly. We can tell it by using the vField component we registered in the previous lecture. We'll start with the input for the name. It's the first input in the form. We'll change the input element with the vField component. The vField component is responsible for validating a single input. It'll generate an input tag by default. It's safe to replace the input element with this component. If we want to override the element it generates, we can add an attribute called as. The value for this attribute is the name of the tag we want the component to generate. For example, if we want to generate a select element, we can pass in select. The original tag was an input tag, so we'll remove this attribute. We don't need it. In the resource section of this lecture, I provide a link to the field component documentation page. If we scroll down, we'll come across a section called Properties. It's a list of properties we can add to the component to modify its behavior. On this list, you'll find a property called as. The as property is the name of the tag the component will output. The default tag is input. It's always a good idea to check with the documentation of the libraries we're using to check what will get rendered. Let's go back to our editor. It's not documented, but any attributes you add to the component are automatically added to the element the component outputs. As long as it's not an official property for the component, it's passively added to the element. We don't need to worry about reapplying the class attribute to the input. The next thing we can start doing is tell vValidate how it should validate the input. There are 4 steps for validating the input. The first step is to replace the input with the field component. We already did that. The second step is to assign a name to the input. We're going to be validating multiple inputs. vValidate needs a way to identify each input. We'll look at how to do that in a moment. The third step is to add the rules. The rules refer to a list of criteria a value must meet for it to be considered valid. Lastly, We need a way to handle errors if the user's input does not pass any of the rules. It's important we give feedback to the user to let them know how they can fix their errors. We're back in the editor. We're going to handle assigning a unique identifier to the input. It'll help vValidate understand our form better. We can add an identifier by adding the name attribute to the field component. We'll set the name to name. We'll move on to the next step, which is to add some rules. We'll look at registering rules in the next lecture. In this lecture, we're going to learn how to define rules. A rule is a function that will take in the input value. The value returned by the function will let the validation library know if the input is valid. Let's take a closer look. By default, vValidate does not assume what requirements an input must meet to be valid. We need to tell it exactly what rules we want to enforce. Not only that, but we also need to tell it what rules will exist in our application. vValidate does not load rules into our application. This keeps the build small and lean. We need to manually import them if we want to use them. Alternatively, we can define custom rules. I find that the rules that come bundled with vValidate will cover most scenarios. Let's import some rules. In the resource section of this lecture, I provide a link to a list of available rules. This page goes over how you can use the rules available in the vValidate library. We'll go over how to use them soon. Scroll down to the section of available rules. There are over 20 available rules. We can test for things like a credit card number, numeric, and URL values. The first rule we'll be using is called the required rule. This rule will make sure the input has a value. We want to make it a requirement for the input to be filled. This is the rule we'll want to add. The first thing we'll need to do is install the rules. The official rules are installable via a separate package. Let's switch over to the command line. If you have the server running, turn it off. After doing so, run the following command: npm install @vvalidate/rules. The rules have been installed successfully. Let's go back to our editor to start using them. The next thing we'll be doing is register the rule. Rules can be registered locally or globally. We'll be performing validation on multiple forms in our application. It would be better to register the rules globally so that they're readily available. Switch over to your editor. At the top of the validation file, we'll import the required rule from the vValidate rules package. Rules are namespaced. We must destructure the object to grab a specific rule. The next thing we'll do is update the import statement from the vValidate package. We'll want to import a function called defineRule. The defineRule function allows us to register a rule globally. The rule we register will be available to every validation form we create. In the install function, we're going to call the defineRule function. The first argument is the name of the rule. You can call this whatever you want. You don't have to use the same names listed on the documentation. The first rule we'll want to create is the required rule. For consistency reasons, we'll call it required. The second argument is a function that'll perform the validation. We don't need to define a function because we're importing the required function from the rules package. Every rule we're importing is already a function. We can pass it in as the second argument. By using the defineRule function, we've successfully registered a new rule. This rule will be available to every validation form. Let's start applying rules in the next lecture. In this lecture, we're going to apply the rules we defined to our forms. Let's use it for our input. Back in the authentication component, we can enforce a rule on the input by binding an attribute on the field component called rules. The value for this must be a list of rules you'd like for the value to be checked against. We're going to set this property to required. This is one way of adding a rule to an input. There's a second way, which is much better. The template in our component is starting to get cluttered. We're adding a lot of code to achieve validation. We can make our template look cleaner by outsourcing the rules to an object. This is the route we'll be going with. We'll remove the rules attribute from the field component. On the vForm component, we'll bind a property called validation schema. The validation schema property allows us to outsource the rules into an object. The value for this property must be an object from our component's data. We'll set this property to schema. This object currently doesn't exist. Let's add it to our component. In the component configuration options, we'll add the data function. In the object, we'll define the schema object. The property name in the object must reference the unique identifier we gave to the input. This would be the value we used in the name attribute on the field component. We want to add rules for the name field. The value for this must be a string with the rules we want to enforce. We'll set this to required. While we're here, we'll add the other fields since we'll be validating them in upcoming lectures. We'll add the following properties: name, email, age, password, confirm password, country, TOS. We aren't going to add rules for all the input at once. We're just adding these in to save some time in the future. We've completed the first 3 steps. The last step is to handle the error. If the input is invalidated, we'll want to provide feedback to the user. There are different ways to handle this. We're going to output a message below the input for displaying the error. There's a component for outputting error messages. It comes with vValidate. It's the easiest way for outputting errors. First, we need to register the component. Switch over to the validation file. At the top, we're going to update the import list from the vValidate package to include a component called errorMessage. Next, scroll down to the install method. We're going to register the component with the app.component function. The name of the component will be the same name as the object. The component we've registered will output an error message. If there isn't an error message, nothing will get outputted. That saves us time from having to check if there's an error message. It's a very simple component. Let's use it. Back in the component, we're going to add the error message component below the field component for the name. We're going to add a class called TextRed600. The error message component will generate a span tag if there's an error. Any attributes we add to the component will be passed onto the element it generates. The class we're adding will change the color of the text to red. The next thing we'll do is tell vValidate which error to output. We'll add a property called name. Its value should be the name of the field it should output errors for. The value should correspond to the value we passed into the name property for the field component. In this example, we're trying to output the error message for the name. We'll pass in name. Each field will have only one error. There can be multiple errors for an input, but the error message component will only output one error. That's perfectly fine. We don't need to view every error on an individual input. We're finished. There are more things we can do, but I think it's time we test the form. In the browser, open the registration form. Everything will look normal. Validation is not performed until the fields have been touched. If we were to input random text into the name field, we wouldn't receive an error. Let's see what happens if we were to leave the field empty. An error will appear below. By default, vValidate generate an error message. The rules we've imported are functions. The functions will return either true or false. We can override this, but we'll get to that in the next few lectures. For now, the default message will work. In this lecture, we're going to continue working with the name field. The goal is to add additional rules. First, I want to introduce alternative syntax for adding rules quickly. We'll continue working on the authentication component. We learned that we could apply rules by adding the rules property on the field component for the name input. The format for adding a rule is to pass in the name of the rule as the value. The name should correspond to the name you assigned the rule in the first argument of the defineRule function. We have the option of using objects for more complex rules. We can use objects by binding the rules property. This binding will allow us to pass in an object. I'll replace the current value with an object. Every property in the object will represent a rule. The key name should be the name of the rule you'd like to add. For this example, let's add the required rule back in. Some rules allow you to configure how they get enforced. It varies from rule to rule. If you'd like to set a rule, you can use the property's value to do so. In the case of the required rule, it doesn't have additional options. If a rule doesn't have additional options, we're required to set it to true if we're using the object syntax. This will result in the same thing as before. This alternative syntax can be handy if you prefer object syntax instead of strings. The benefit of using an object is it allows you to outsource the rules as a data property. If you have too many rules, then converting it into an object may be beneficial for readability. We won't be using the rules object on the field component. We already have the validation schema property set to an object for outsourcing our rules. I prefer to use the schema because we can centralize our inputs rules in one object. Let's work on adding some more rules. Open the validation file. We're going to add 3 rules called minimum, maximum, and alpha spaces. We'll update the import statement to include these rules. The minimum rule will check if the input is not less than a specific length of characters. This rule is to prevent users from entering one character in an input and moving on. The maximum rule will check if the input is not greater than a specific length of characters. In some cases, you may have a database where there's a character limit that you can't exceed. You don't want to allow users to insert large strings because that will take up unnecessary space. It's always a good idea to set a maximum limit. The alpha spaces rule will allow the input to contain alphabetic characters or spaces. People don't typically have names with numbers or other characters. We'll want to limit the character set to alphabetic characters and spaces. In the import statement, we're assigning the alpha spaces rule an alias. This is because we have an ESLint rule that does not allow underscore characters for import names. We have to use camel casing. The alpha spaces object uses an underscore character. To prevent ESLint from throwing an error, we're using an alias to convert it into camel casing. A minor inconvenience. We're still going to use the underscore for its name when we register it. After importing the rule objects, we're going to register them with the defineRule function. The next step is to use the rules. Switch over to the authentication component file. Scroll down to the schema object in the data function. If we want to add additional rules, we can separate each rule with a pipe character. Let's add the 3 rules we registered. We'll start with the minimum rule. Unlike the required rule, the minimum rule has an option for setting the minimum character length. To set the option, we need to add a colon after the rule followed by the value. We'll set the minimum character length to 3. Afterward, we'll add the maximum rule. We'll set it to 100. This rule will limit the field from having more than 100 characters. The last rule we'll add is alpha spaces. There are no options for this rule. We have a total of 4 rules. Let's test if they work. Back on the browser, try inputting a single character into the input. we'll receive an error telling us that the field is invalid. It would be better if the error were more descriptive. We'll look at customizing the error message in a future lecture. I'm going to type some additional characters. The error will go away. I should be allowed to input spaces if I want. If I were to input a number, then the alpha spaces rule will get broken. It'll only allow us to input alphabetic characters or spaces. This is great. The rules are being enforced like we want them to. There are two things I want to talk about before ending this lecture. Firstly, vValidate follows a fast exit strategy. By default, it'll stop validating the input field upon encountering an error. In a way, this makes sense. There's no use in checking the rest of the rules if one rule has already been broken. This results in better performance. It even provides a better user experience because the user will receive feedback faster. There is a way to output multiple errors. We'll look at an example in a future lecture. Secondly, validation will not be performed on an empty field until the initial value has been changed. You'll notice that we don't receive an error when the form first appears on the page. vValidate will not enforce the rules until the input has changed its value. This behavior is beneficial to us. We don't want to start displaying errors to users when they haven't even had the chance to fill it out. Otherwise, it would be annoying. That wraps it up for this lecture. We'll continue in the next one. In this lecture, we're going to focus on validating the email. The process is the same as before. As an exercise, try validating the email field. Be sure to output a message if there's an error below the input field. Refer to the documentation for the list of rules available. Don't feel pressured to use as many rules as you can. Keep it simple and use what you think is right. Pause the video and good luck. Welcome back. If you are able to validate the email field, then congrats. If not, that's fine as well. Let's go over it together. Open the authentication component file. In the template, search for the email field. The first step is to convert the input into the field component. We'll change the input element to the vField component. The field component will output an input element. Next, we'll give the input a name. We'll set the name to email. Afterward, we'll give the input some rules. We're using a validation schema to list our rules. Scroll down to the schema object in the data function. The rules will be the following. Required, minimum set to 3, maximum set to 100, email. We're using the same rules we use for the name field except for the alpha spaces rule. Emails typically don't have spaces. You're not required to set these rules in any particular order. I prefer to set the required rule first because I think it's worth checking before any other rule. I'm introducing a new rule called email. It'll check if the input is a valid email. However, we'll receive an error because we haven't registered it. Let's register it as a rule. Open the validation file. We won't have to create an email rule because vValidate comes with one. We can import the email function from the vValidate rules package. In our install method, we can call the define function. We'll set the name to email with the email function. After registering the rule, we can use it in our component. We've already listed it as a rule for the email field. We can move on to the final step, which is to output the error. Switch back to the authentication component file. Below the field component, we're going to add the error message component. We'll add the text red 600 class to change the text color to red. Lastly, we'll set the name property to email. We're finished. Let's switch over to the browser to test if it works. Check the console for any errors. There shouldn't be any. After confirming there are no errors, try testing the registration email field. An error will appear if you try entering an invalid email. vValidate considers an email valid if it has the @ symbol with the domain extension at the end. If I were to input test@test.com, then that will result in a successful validation. We've successfully validated the email field. Let's move on to the other fields in the next one. In this lecture, we're going to continue validating the fields in the form. The next field in the form is the age. A lot of this will be similar to before, so let's jump right into it. We'll be working in the authentication component file. In this component, search for the age input in the template. It's below the field for the email. We'll change the input element to the field component. One thing you'll notice is that we have the type attribute set to number. The type attribute for the email is also being set. vValidate will modify the type of the input element it generates. This is why we don't have to remove or do anything else to get the desired type. The attributes are passed onto the element the component generates. The next thing we'll do is set the name of the field by setting the name attribute to age. Keep in mind, the names we're using on our fields should correspond to the names we're using in the validation schema. This is how vValidate will know where to enforce the rules. Speaking of the validation schema, let's scroll down to the object to add some rules. In some instances, you may want to have a minimum age requirement. The minimum rule will not work in this scenario. It'll consider non-numeric characters to be valid. We want the rule to validate numeric values only. Any non-numeric character should throw an error. There's an alternative rule available called minimum value. It'll check if the input is numeric and doesn't fall below a specific number. We'll need to import and register it. Open the validation file. In the import statement for the rules, import the minimum value rule object. We're going to assign it an alias called minimum value. This alias is to prevent ESLint from throwing an error because the minimum value rule uses underscores. Underscores for import names are not allowed. While we're here, we're going to import another rule called maximum value with an alias of maximum value. We'll want to make sure no one is registering with a ridiculous age like 300. Adding a rule for checking for a maximum value will help us with that. Let's register the rules. Call the defineRule function twice for both rules we imported. We're going to keep the underscore characters in their names intact for consistency. We don't need to import any more rules. These will suffice for the age. If you would like to add more rules, then go ahead. Switch back to the authentication component file. We'll add the following rules to the age field. Required, minimum value, maximum value. The minimum and maximum rules allow us to set the thresholds. For the minimum value rule, we'll set it to 18. We want users who are 18 years or older. The maximum value rule will be set to 100. Some people are over 100 years old. This is just an example. Feel free to bump it up. Let's move on to handling the error. Scroll back up to the age field. We'll copy the markup we used for the other errors. We'll copy the error message component from the email field and paste it below the age input field. We'll need to update the expression to output the error for the age. At this point, we're repeating the same thing. However, it does give us the opportunity to explore different rules. Let's verify that the age field is being validated. Switch over to the browser. I'll attempt to break the rule for non-numeric characters. We will receive an error. Next, we'll test the rules for when a value is outside the bounds of the range we set. Another error. Great. The age validation is working like we wanted. In the next lecture, we'll work on the password fields. In this lecture, we're going to validate the password fields. We have two of them in our form. The second field is to verify the password. We want to check that the user is sure about their password. vValidate has a rule for checking if two fields match. We'll learn about what that rule is in a moment. First, we'll focus on preparing the fields. Under the age field, you'll find the password field. We'll change the input field to the field component. We'll set the name attribute to password. Next, we'll begin adding the rules. In the schema object, we'll use the following rules for the password field: required, minimum, maximum. Throughout this section, you'll notice I've been setting a minimum and maximum cap for each input. This rule set isn't required, but recommended. Most databases will usually come with a limit on how much data can be inserted into it. While it's not your responsibility to manage the database, it's always good to ask or check what the limits are. This will allow you to import those limits in your forms. The limits I'm using are ones I use in real applications. Feel free to follow along. Sometimes you may need to use different limits. Increase or decrease the limits as you see fit. The next step is to work on outputting the error. We'll use the same markup for the other input fields. Scroll back to the password field. Copy and paste the markup for the error message from any other inputs we've already validated. Paste it below the password field. The name property will need to be updated to password. We can work on the next input. Same process as before. The confirm password field can be found directly below the password field. We'll do the same thing we did to the other components. Change the input element to the field component. We'll set the name attribute to confirm password. Up next, we need to add the rules. We're not going to use the same rules we used for the password field. It's not necessary to apply the same rules. The purpose of the confirmation password field is to double check that the user correctly inputted their password. The rule we'll want to use should check if the input matches the input in the password field. This can seem a little tricky, but luckily vValidate comes with an easy-to-use solution. First, we'll need to import and register the rule. Open the validation file. Import a rule called confirmed. In the install method for the plugin, we'll add the confirmed rule with the define rule function. The confirmed rule will check if the value inside the current input matches a value in another input. Let's learn how to use it. Switch back to the authentication component file. Let's go to the schema object in our data function. We'll add the confirmed rule to the confirm password field. The confirmed rule requires we pass in the name of the field the current input should match against. We'll set this rule to @password. The value must correspond to the name we assigned to the field component with the value we're checking against. The @ symbol is required. It'll tell vValidate to search for a field with this name. This rule will tell vValidate to search for a field component with the name password. The last thing we'll need to do is add the error. Let's scroll back up to the template. We'll copy the error message component from one of the previous fields. Then, we'll paste it below the confirm password field. We'll change the expression to password confirm. We're finished. Let's open the form in the browser. We'll input some values for both fields. If both passwords don't match, we should see an error telling us that they don't match. We'll receive an error from vValidate. If we were to make the passwords match, then the error will go away. Great! We're finished with the name, email, age, and password fields. We were able to cover some additional rules. A lot of the rules we covered can be reviewed by visiting the documentation. We've still got a few more fields to validate. Let's finish this up in the next couple of lectures. We've almost finished validating the form. The next two fields are the country and terms of service fields. One is a drop-down and the other is a checkbox. Fortunately, even though they're different elements, the process of validating them is still the same. In this lecture, we'll take the time to explore more rules and scenarios you may run into when validating a form. Let's start with the country field. In the template, search for the Select element in the form. It'll be a drop-down for a list of countries. We'll change the Select element to the vField component. The element the field component will generate will be an input element. We want to override this behavior. We can change the name of the tag by adding the As attribute to the component. We'll set this to Select. This value will generate the desired tag. Inside the contents of the component, we're passing in the options for the dropdown. vValidate will take care of passing these on to the Select element. We don't need to modify the contents of the component. The next thing we'll do is assign a name to the component. We'll set the Name attribute to Country. We can work on the rules next. The advantage to using a dropdown is limiting the possible choices. We don't have to worry about formatting. That makes things easier because we don't have to add as many rules. We don't need to worry about a minimum or maximum character length. This makes things straightforward. We'll want to add the required rule because we want the user to make a choice. In the Schema Data object, we'll update the rules for the country field. We'll set it to required. Lastly, we'll deal with the error. We'll use the same HTML we used for the other error messages. Copy the error message component from any of the other inputs. Paste it below the drop-down of countries. We'll update the Name attribute to Country. The country field is pretty much ready. It's not very interesting. Let's add a special rule for excluding a specific value for fun. Let's say, sometime in the future, you may want to prevent an option from being selected. For example, let's say a problem occurs in a country on this list. A new law or regulation has been passed that prevents us from providing service to that country. In the meantime, you need to prevent users from this country from registering. We can add a rule that will prevent users from registering if they select a certain option. Let's add a new option to the drop-down called Antarctica. I'm well aware that Antarctica is a continent and not a country. We're adding it in as an example of a location we can't provide service to. If the user selects Antarctica, we'll want to let the user know that they can't select that option. First, we'll need to register the rule. Open the validation file. The rule we'll want to import is called NotOneOf. It's a weird name. I prefer to rename it to Excluded for a better description of the rule. Then, we'll register the rule by calling the DefineRule function. The excluded rule will check if the value is in a list of invalid values. If it is, it'll throw an error. Switch back to the authentication component file. We're going to add the excluded rule. The option is the list of values the input must not match. We'll add Antarctica. This rule will assume every value is a string. If you want to add more invalid values, you can separate them with a comma. We're almost finished. The very last field is a checkbox. Validating a checkbox is relatively simple. Unlike the other input fields, we don't have to worry about validating the value because it's predetermined. The only thing we need to check for is if it's ticked. We want users to agree to the terms of service before registering. Let's go over to the checkbox in our form. We'll convert the input element to a field component. Another attribute we have to set it, the Name attribute. We'll set it to TOS. One last thing. We need to add a value to the checkbox if it's ticked. We'll set the Value attribute to 1. By default, The field component will use undefined as the value. We want to make sure there's a value. Otherwise, any rules we add will always be broken. Let's work on adding some rules. In the schema object, we'll add the required rule to the TOS field. The last thing we'll work on is the error. It'll be the same procedure. We'll go back to the template. We'll need to copy and paste the same error message we had for the other inputs. I'll grab it from the other inputs. Lastly, we'll update the expression to TOS. That will finish things up. There aren't any more fields we need to validate. Let's test the validations we created for the two fields. Switching to the browser, we'll check the console for any errors. There aren't any errors so far. Next, I'll test the country field. By default, it won't have an initial value. If I were to change the value to Mexico or Germany, then nothing happens. However, changing it to Antarctica will break the excluded rule. It'll output an error. This is the exact behavior we were looking for. As for the terms of service, the error doesn't appear even though it's required. Validation is not performed until the input has been touched. The default behavior is fine. This is because the form component will force validation on submission. We'll learn how that works when we start working on form submission. For now, we'll test the checkbox by checking it and then unchecking it. The rule is being enforced. Our form is completely validated. Now that we've validated every input field, we can move on to the next step. By default, validations are not performed until the input fields have been touched. In some cases, a user can accidentally skip a field and submit the form. Any fields that were skipped will not be validated. We don't want that. We want the validation to be performed and inform the user when that happens. That's what we'll be doing in the next lecture. When you're ready, I'll see you there. We're almost finished with validating the form. Each individual field has its rules applied to it. The next thing we'll want to do is validate the entire form if the user attempts to submit it. If the user attempts to submit an incomplete form, we will need to force validation on inputs before processing the request. The way vValidate handles validation is by waiting for the inputs to be interacted with. It will not validate the moment the user lands on the page. We will need to force validation if the user doesn't trigger the validation on their own. vValidate makes it extremely easy for forcing validation. Open the authentication component in your editor. We're going to be focusing on the form component we wrapped around the inputs. On the form component, we'll add an event listener for the submit event. The submit event is slightly different from the submit event for a form. vValidate creates its own version of the submit event. It'll do two things. First, it'll force the field component placed inside it to perform validation. This enforcement includes inputs that haven't been touched. If any of the inputs are invalid, the event will not run the expression. Second, it'll prevent the page from refreshing upon submission. We don't need to add the prevent modifier. It's done for us behind the scenes. Let's add the function we want to run if the forms are valid. We'll pass in a function called register. We never have to worry about manually checking if the forms are valid. The register function will not be called if any of the inputs are invalid. Any untouched fields will have their errors rendered. This will inform the user of what inputs they need to fix. The next thing we'll do is define the register function. Scrolling down, we'll define the register function in the methods object. If the register function gets called, we know for sure that the values in the form are good to go. The submit event will provide our function with the values from the field components. Throughout this section, we never used the vModel directive to bind values to our inputs. It's not necessary to use the vModel directive in our form. vValidate comes with its own system for keeping track of the data in the form. This doesn't mean the vModel directive isn't helpful. However, we don't need the vModel directive since the library will keep track of the values for us. Inside the register function's parameters, we'll add a parameter called values. Next, we'll log this parameter. This log will let us know if the validation was a success. Let's give this a test. Refresh the page on the browser. We want a clean slate. If you're using a browser that autofills the input fields, then don't worry about it. Just empty them out. Submit the form without inputting anything. This submission will trigger an error in every field. In the console, we won't see anything because the register function was not called. The form component will not run the register function until the fields are valid. I'm going to fill out the form with valid values. If I were to submit the form again, we'd see our values logged in the console. This is great. We have a way to prevent the form from being submitted if there are any broken rules. We can proceed with submitting the data. There are some additional optimizations we can make before submitting the data. We'll look at what else we can do to make the form more user-friendly in the upcoming lectures. Welcome to this sidebar. Sidebars are lectures you don't have to take immediately. It's a lecture you can revisit later whenever you want. It's not required to watch this lecture to continue on with the course. It's completely independent. I throw in sidebars to provide additional information about a topic. In this lecture, we're going to discuss what slot properties are and how they work. They're a topic we're going to encounter in the next lecture. I want to use this opportunity to discuss what slot properties are before diving back into validation. We're going to be working on a separate project for this topic. In the resource section of this lecture, I provide a zip file. Download it, install the packages, and start the server. Pause the video if you need to. Let's quickly review the files. I generated the project with the default preset. Slot properties are a Vue feature. It's not required to install any other library aside from Vue. I've made modifications to two files. The app and Hello World component files. We'll start with the app component. Inside this file, we're importing and registering the Hello World component. There's nothing else going on in the script block. In the template block, we're using the Hello World component with opening and closing tags. We're going to add slots to the component, so we'll need to use opening and closing tags. Open the Hello World component. The template block has an empty set of div tags. We're going to add slots to it in a moment. In the script block, the data function is defined. There are two properties called user and favorites. The user property contains random information about a user. The favorites property is a list of their favorite things. The data is not being used anywhere in the application. You can safely ignore it for the time being. We'll get to it soon. The objective is to add slots to the Hello World component. This way, we can allow for content to be inserted. In between the div tags, add the slot component. We're not going to assign it a name. It's going to be the default slot. Let's switch over to the app component file to insert some content. Inside the Hello World component, we'll add a paragraph element with the following message: Hello World. This will result in the message appearing in the slot we have in the Hello World component. Switch over to the browser to view the message. It's getting inserted like we wanted. That's great. We'll want to take it to the next level. Back in the editor, we'll want to make the content more dynamic. The message is static. It would be great if we could update the message to greet the user. The user information is stored in the Hello World component. Theoretically, we could move the data from the Hello World component to the app component. However, there's an alternative approach we can take, a much more flexible one. We can use slot properties to pass information to a slot's children. Let's look at how that's done. In the Hello World component, we're going to bind a property to the slot component. We'll call the property user. The value for this will be the user property we have in the data object. By binding a property to the slot component, it'll become available in the parent scope. In this example, the parent scope is the app component. We'll switch back to the app component. If we would like to use the user object in the content, we need to add the vSlot property to the Hello World component in the template. The vSlot property requires an alias for the list of slot properties. We're going to call it v. The v alias will represent every property bound to the slot component. We're binding one property, which is the user data object. We can use it in our content. I'm going to replace the word world with the expression v.user.name. The name we selected for the alias is entirely optional. It's common practice to name it v or slot props. Let's give things a test. Switch over to the browser to view the app. On the page, we can see that the message has been updated. It's greeting the user by their name. This output is precisely what we wanted. Slot properties allow you to send data to the parent scope. There are a couple more things I want to go over in regards to slot properties. First, the vSlot directive is available in versions 2.6 and up. It's a new syntax feature added to Vue. It simplifies the process of using slot properties. Secondly, there's a shorthand syntax for using slot properties. Let's go back to the editor to use it. We can altogether remove the vSlot directive from the Hello World component. The shorthand syntax is the pound character. We're required to set the name of the slot after the pound character. By default, if we don't set a name for our slot, it'll be set to default. We'll need to add default after the pound. Another handy feature of slot properties is being able to destructure the object. You can bind as many properties to the slot component as you'd like. If you're only going to use one or two properties, you may want to consider destructuring the object. I'll destructure the object to retrieve the user property. Then, in the template block, we'll update the expression to user.name. This can hopefully shorten some of the code you have to write. Let's view the browser to check for breaking changes. The name still gets rendered. There's not much else to slot properties. You can create as many slot properties as you'd like. Back in the editor, let's switch to the Hello World component. As an exercise, try binding the favorites data property to the default slot. Then use it in the app component. Pause the video and give it a try. Welcome back. If you were able to add a new slot property, then congrats. If not, that's fine as well. We'll do it together. Open the Hello World component. We'll bind a property called favorites to the slot component. Its value will be set to favorites. By the way, you don't have to keep the names the same. You can call this whatever you want. I recommend keeping the names the same for consistency. The favorites data property is available in the parent scope. Let's use it. Switch to the app component file. In the template block, we'll need to destructure the favorites property from the object. It's important to destructure the object. Otherwise, we won't be able to access the favorites array. After destructuring the array, we're going to add on to the message, I like favorites 0. The favorites data property is an array. We're accessing the first item in the array. If you'd like, you can loop through the items. We'll keep it simple by outputting the first item in the array. Let's view the app in the browser. The message renders the first item in the favorites array. That's great. We've successfully learned how slot properties work. They're handy for passing on data to the parent scope. In the resource section of this lecture, I provide a link to the Scoped Slots documentation page. This page will provide you with more information and examples of slot properties. I recommend reading it after you've finished this lecture. In the next lecture, we'll continue with form validation in our project. The next optimization we'll work on is outputting multiple errors. So far, we've been outputting a single error rather than all of them. This is so that we don't overwhelm the user with errors. It would clutter the form visually. However, in some cases you may want to output multiple errors for a specific input. An example of this would be the password field. I'm sure you've encountered a fair number of password fields. They vary with their own rules. Some examples would be requiring a minimum character length, using various characters, or using numbers. This is so that the user has a strong password. It would be annoying to type out a password only to learn that it's missing something. It would be preferential to render every error. This will allow the user to adjust their password based on our rules. Keep in mind that this is just my opinion. There are different ways to tackle user experience. It depends on the app you're building. Regardless, I think this would be a good example of how to output multiple errors at once. Search for the password field if you haven't already. We're going to focus on the first field because the second field will match the first one. It's not required to repeat the rules. If the first input isn't valid, then neither is the second one. vValidate implements a fast exit strategy. It's a strategy that'll end the validation process if a single rule is broken. If there are additional rules, they won't be checked. This results in fewer resources and faster feedback. This is why you'll only see one error at a time for an input. We'll want to override this strategy if we want to output multiple errors. On the field component, we're going to bind a property called Bails. We'll set it to false. The Bails property will tell the field component not to use the fast exit strategy. This means every rule will be checked even if a previous rule was broken. It's important to bind the Bails property because we want the component to interpret the value as a false Boolean value. The next step is to loop through the errors. Here's where a new problem arises. Currently, we're using the error message component to output the errors. However, it'll only output one error at a time even if the Bails property is added to the component. We're going to need to customize the behavior of the field component if we want to output multiple errors. The field component has a slot we can take advantage of. It's the only way we'll be able to output multiple error messages. We're going to create an opening and closing field tag. Since we're going to add some content, we need to output the input tag. vValidate will not do it for us. Inside, we'll pass in an input tag. We'll cut and paste the placeholder, class, and type attributes from the field component to the input tag. Next, we need to tell vValidate which input should be validated inside the slot content. We're going to add the vSlot directive to destructure the field property. The field property is an object with the features for adding validation to an input. We must add this property if we want to validate the input. Otherwise, vValidate will not be able to perform validation on the password field. We can bind the property by adding the vBind directive to the input element. We'll set it to field. Next, we'll work on the error. Below the input, we're going to add a div tag with the class text red 600. We're using a div tag because we'll be outputting multiple errors. Each error should be placed on a separate line. The div tag will assure us of that. From the vSlot directive, we're going to destructure an array called errors. The errors array will contain a list of errors triggered by the input. It's important to understand that the array will only be available if we set the Bails property to false. Otherwise, we'll always get one error. We can loop through this array to output the errors. On the div tag, we'll add the v4 directive. The expression will be the following: error in errors. Inside the tags, we'll output the error with an expression. One last thing, we'll need to add a key. We'll bind the key attribute to the error alias in the loop. This attribute isn't necessary, but Vue recommends we set it anyway. We're almost finished. The last step is to update the rules for the password. At the moment, we don't have a pair of rules that will appear along each other. Scroll to the schema. In the password field, set the minimum rule to 9. Next, set the excluded rule to password. Allowing users to set their password to password is not considered to be a safe practice. We should prevent users from using specific passwords during registration. We're finished. Save your changes and refresh the page. I'm going to type password into the password field. This input will cause the minimum and excluded rules to break. The messages are the same because vValidate uses the same message for every rule. As long as you see multiple error messages, then you're good to go. We'll continue optimizing the form in the next lecture. There's one last optimization we'll want to make. In the form, the country dropdown will not have a default value. It appears as if it's empty. We'll want to force a default value, which is normal for dropdown fields. Let's learn how to do that. Let's go back to the editor. In the component, we're going to scroll down to the data function. We'll define a new property called userData. Its value will be an object. Inside this object, we'll add initial values for the fields. The property name in the object must correspond to the name assigned to the field in the template. We're going to add the country field to this object. The value for this must be the initial value we want to give to the field. We'll set it to USA. The next step is to tell vValidate that we want to use these initial values in our form. We're not setting initial values for every input. We only need to add the ones we want to have initial values. Scroll up to the form component. We can add a property called initial values on the component. We'll bind this to the userData property. The form component will use this object to apply initial values to the respective fields in the slot content. Let's refresh the page on the browser to view the registration form. The country dropdown is selecting the USA option by default. By using the initial values prop on the form, we can configure the form to have some default values. We're finished with adding some default values. We won't have default values for the other inputs. It's fine to leave them empty. Up until now, we've been stuck with the same error message for every rule. The reason we get the same message is because of how rules are defined. In the validation file, we're using the defineRule function to create our rules. The second argument to the function is a pure function. The pure function can return one of two values. It can return true if the validation passes, or it can return a string. If it returns a string, then the validation fails. The string must be a message to tell the user why the validation failed. It's important to understand this. We aren't creating our own rules. Instead, we're using rules from the vValidate rules package. The functions we're importing don't return a string if a validation fails. They're returning a false Boolean value. vValidate provides a way for overriding a message. There are some limitations to what we can override. Firstly, we can only overwrite messages from global rules. Keep in mind, we're allowed to define rules locally. A local rules error message cannot be overridden. The second thing to understand is that this will only work for functions that return a false Boolean value. If the functions from the package returned an actual string, we wouldn't be able to override those messages. Luckily they do, so we'll be able to override them. Let's explore how that's done. We're going to create the custom messages in the validation file. At the top, we'll update the import statement for the configure function. The configure function can be used to configure the default behavior of the validation library. We'll be able to override the default messages from our global validators. Inside the install method, we'll call the configure function. This function has one argument, which is an object with the configuration options. There's one option we'll want to add called generate message. This option will be an arrow function where we'll have access to a parameter called context. The generate message function will be called whenever a global validator function returns false. This function will handle all global validators. Inside the function, we must return a string that will represent the message we want to output to the document. The context parameter is an object information about the field being validated. We'll have access to the name, value, and rule being broken by the field. We can use it to help us output different error messages based on the rule being broken. Inside the function, we're going to write a message for every global rule we defined in the install method. We'll start from the top and work our way down. We'll declare a variable called messages. It'll be set to an object. We're going to add a property for every rule. The name of the property will correspond to the name of the rule. It's crucial we use the same name because it's how we'll be able to search for the rule when we need to output it. You'll see what that looks like in a moment. The first rule is called required. Its value will be the following. The field context.field is required. From the context object, we can access the name of the field via the field property. We're using a string template for inserting the name into the string. We'll keep moving forward. The next rule is called min. Its message will be the following. The field context.field is too short. Then we have the max rule. The message will be the following. The field context.field is too long. Subsequently, we have the alpha spaces rule. The message will be the following. The field context.field may only contain alphabetic characters and spaces. Afterward, we have the email rule. The message will be the following. The field context.field must be a valid email. Up next, we have the min value rule. The message will be the following. The field context.field is too low. Similarly, we have the max value rule. The message will be the following. The field context.field is too high. There are two more rules left. We're going to approach these two slightly differently. The excluded rule will check if the input does not match the list of values. However, the excluded rule can be used for other scenarios. We have to choose between a generic or specific message. However, there is a solution where we can have both. We're going to add the excluded rule to the object. The message will be the following. You are not allowed to use this value for the field context.field. This message works great, but we want to give a more specific message in the registration form. We want to tell the user that they're not allowed to sign up for a certain location. One way we can add messages for specific inputs is by creating a rule specifically for the field. Let me show you what I mean. We're going to make a copy of the excluded rule. The name will be country excluded. We have two rules that do the exact same thing. However, they have different names. This allows us to create a message for generic scenarios and another for specific inputs. Back in the messages object, we can add this rule to the list. We'll set the message to the following. Due to restrictions, we do not accept users from this location. Great, we have a special message for the country field. We're going to update the name of the confirmed rule to passwords mismatch. We aren't going to create a copy because we'll only be using this rule once. we don't need to create a generic message. Inside the messages object, we'll add the passwords mismatch rule. The message will be the following: the passwords don't match. There's one last rule we'll add. The default message for the terms of service doesn't sit well with me. The terms of service are using the required rule. We want to tell the user directly they must agree to the terms of service. We'll make a copy of the required rule because we'll need one copy for generic scenarios and another for the terms of service. The name of the copy will be TOS. In the messages object, we'll add the following message for this new rule: you must accept the terms of service. We have two rules that do the same thing. They require the user to input a value. The difference being is the message. The required rule can be used for regular inputs, while the TOS rule is specifically for the terms of service checkbox. We're finished writing the rules. The next thing we'll do is tell vValidate which message to use. We'll declare a variable called message. Its value will be a ternary operator. In the condition, we'll check if the message's context.rule.name exists. The rule.name property refers to the name of the rule that was broken. We want to check if a message for this rule exists. If it does, we'll set the message variable to it. Otherwise, we'll have a generic message which will be the following: the field context.field is invalid. Afterward, we'll return the variable. We're not going to add any more custom error messages. There's one last thing we need to do. We'll need to update our form to use the custom rules we created in the object. Switch over to the authentication component. We'll need to update the schema data property. For the password confirm field, we'll change the rule confirmed to passwords mismatch. Next, the country field will have its excluded rule changed to the country excluded rule. Lastly, the TOS field will use the TOS rule instead of the required rule. Let's give things a test. Open the app in the browser. First, we'll test the country selection. I'll select Antarctica. The error will tell us that we're not allowed to register from this location. This is a much better message than before. Next, let's test the terms of service checkbox. If we were to uncheck the box after checking it, we'd see the custom error message. Even though the name of the rule is different, it'll still work because the configuration is the same as the required rule. Lastly, let's test any of the other fields with the required rule. We've successfully created error messages for the other fields. One of the most important things I want you to be aware of is how we handle generic and non-generic messages. We had copies of the same rules under different names. This allowed us to maintain generic messages while also handling special cases. In this lecture, we're going to talk about validation triggers. vValidates can be configured to validate an input on different events. If we want, we can go with an aggressive validation tactic for validating inputs. First, let's understand the default behavior as to when an input is validated. Validation is performed on one of four occasions. If the input field emits the change event, validation will be performed. The change event is emitted whenever an alteration is made to the element's value. The second occasion is when the value changes internally via JavaScript. It's possible to add the vModel directive to an input. If we decide to add the vModel directive, vValidate will watch for changes on the property we have bound to the input. If a change occurs internally, validation will be triggered. The third occasion is when the blur event is emitted. The blur and change events can sometimes occur at similar times. The difference between them is the blur event is fired when the user touches an input and moves away. It doesn't matter if they changed the input. As long as it was touched, the event will be emitted. The last occasion is when the form is submitted. All fields will be validated. vValidate allows us to change when an input is validated. We don't have to stick with the default strategy. We are going to be working in the validation file. Open it in your editor. We can change the validation trigger on all fields by updating the object we passed into the configure function. There are 4 options we can set to change the default behavior. Let's run through them one by one. At the end of the object, we're going to add a property called validateOnBlur. Its value will be true. The validateOnBlur option will tell vValidate if it should validate a field on the blur event. By default, this option is set to true. You can set it to false for a less aggressive behavior. The next property we'll add is called validateOnChange. Its value will be true. The validateOnChange option will tell vValidate if it should validate a field on the change event. The default value is true. Afterward, we have the validateOnInput option. We will set this to false. This option is probably the most aggressive validation trigger. The input event is fired whenever the input changes. It's different from the change event because it'll fire on every keystroke. The moment a user presses a key, if the value is invalid, an error will appear immediately. This option may be appropriate for inputs like passwords, but it's excessive for most inputs. Users don't like to have errors thrown at them immediately. It's better if we wait until they have finished filling out the field. However, that's my opinion. Feel free to turn this on. The default value for this option is false. The last validation trigger is called validateOnModelUpdate. The default value is true. This option will tell vValidate to validate the input whenever the value changes internally through the vModel directive. A total of 4 options to change the validation triggers. We are using the default values because I think the default behavior works fine for our case. I wanted to show you these options in case you need to change the default behavior. In the next lecture, we'll continue working on validation. Before we declare this form finished and move on to authentication, I would like to display a message to the user to let them know their submission is currently in progress. vValidate doesn't provide anything to help us with this, but we can accomplish this with Tailwind. The goal for this lecture is to render a waiting message to the user. Submitting a request can take a while. We'll want to let the user know we're processing their request. Alert boxes are a great way to communicate that. Let's get started. Open the authentication component file in your editor. The first step is to create some data. We want to be able to store the variant, message, and visibility of the alert box. We can store this inside the state, but the data we're creating will be used in the authentication component. The data won't be used globally. It's not something we need to clutter our state with. If you prefer to define the data in the state, then that's fine. Inside the data function, create a property called registrationInSubmission with a value of false. The first property we're creating will keep track of if the registration form is in submission. We'll want to disable the form if the request is still processing. I'll expand on why this is important to keep track of later in the lecture. Afterward, we'll create a property called registrationShowAlert with a value of false. Initially, we will want to hide the alert box. We will use this property to toggle its visibility. By default, we'll leave it at false. The next property we'll create will be called registrationAlertVariant with a value of BGBlue500. We are going to have different colors of the alert box. We are going to be using the color blue to indicate the form submission is in progress. You'll see how this class will affect our alert box in a moment. Let's keep going. The last property we're going to create is the message. We'll call it Registration Alert Message. Set it to the following. Please wait, your account is being created. The message property will be used for the inner content of the alert box. We'll be changing this to let the user know the status of their form submission. The properties are ready. The next step is to add an alert box to the template. Scroll to the top of the registration form in the template. We're going to add a div tag. It'll have the following classes: text, white, text, center, font, bold, P4, rounded, MB4. You can refer to the Tailwind documentation for information about these classes. It'll give us a box with spacing to display the alert message. We're going to bind our properties to this element. First, we're going to hide the element with the VIF directive. The condition will be the registration show alert data property. Next, we'll change the color of the background color of the box. We'll bind a class attribute to the registration alert variant data property. Lastly, we'll output the message by adding an expression inside the div tag. We'll output the registration alert message data property. We're finished prepping the component in the template. The next thing we'll want to do is to disable the submit button if the form is currently in submission. Scroll to the bottom of the form element to find the submit button. We'll bind the disabled attribute to registration in submission. It's crucial we do this. One of the most overlooked steps for beginner developers is not to take into account of spam submissions. There are users out there that will submit a form repeatedly even if the first submission worked. This behavior can turn out to be costly because more requests mean more resources are taken up, which will result in higher production costs. This may not seem like a big deal at first because it's one form. Let me show you an example of how disastrous this can become. In the resource section of this lecture, I provide a link to an article about a company that spent $30,000 in 72 hours due to an error in their code. I recommend giving this a good read. In summary, they didn't properly account for the number of requests made to their database. By overlooking one small part of their code, they incurred large expenses. The situation is different, but the overall lesson is still the same. You always want to make sure that you never allow the user to make excessive requests. One simple method of preventing excessive requests is by disabling the form until the submission is complete. It's not foolproof. There are ways to bypass or override the behavior we created. At this point, it's usually left to the server or backend developers to handle excessive requests. This will stop the most basic types of attacks or accidents we may face when our application is deployed to production. By default, the in-submission data property will be set to false. This value will make the button clickable. We're finished with modifying the template. We have the data ready, and the data is hooked up to the template. The very last step is to update the data in the register function. The register function is where the request will be handled. Scroll to the register function in the component. If there's any code in the register function, remove it. We'll want to start with a clean slate. Inside the function, we're going to set the registration show alert and registration in submission properties to true. The show alert property is responsible for toggling the alert's visibility, whereas the in submission property will disable the form button. Up next, let's set the variant property to BGBlue500. We're doing this because we need to reset the variation while it's in submission. In some instances, the user may have already submitted the form. We'll change the variant depending on if the request was a success or not. Either way, if they're submitting the form again, we'll need to reset it. This same logic applies to the message. We'll need to reset the message property. We're done setting the initial state of the alert component. The next step is to begin submitting the request. We'll handle that in the next section. There's one last thing I want to do. I want to create a dummy response. The code for submitting a request is something we'll write in the next section. In the meantime, we're going to tell the user that the request was a success. We'll set the registration alert variant property to bggreen500. Next, we'll set the message property to the following. Success! Your account has been created. We aren't going to enable the button again because we'll want to redirect the user after their account has been created. We'll worry about that later. The last thing we'll do is log the values parameter. Save your changes and view the app in the browser. Open the console to inspect for any errors. There shouldn't be any so far. Try filling out the form and then submit it. We'll receive a success message after submitting the form. The button will remain disabled since we didn't toggle the value back to false. We're finished. To review everything, all we did was use the alert component to render the status of the user's submission. We created 4 properties for disabling the button, showing the alert, changing the variant, and the message inside. Communicating the current status of the submission provides for a better user experience. In the next lecture, we'll start working on the login form. The main goal of this section is to go over form validation. In the next section, we'll store the form data in a database. We'll use that data to authenticate a user into our application. Before we get into that, I want to prepare the login form. Validating the login form is the same process as validating the registration form. The only difference is that there are 2 fields instead of 7. This is a perfect opportunity to test what you've learned. You already have the knowledge to validate the login form. Try validating the form on your own. Get as far as you can. Use any rules you like. Try to replicate the same behavior we had for the registration form. Good luck! Welcome back. If you were able to validate the form, then congrats. If not, that's fine as well. Let's do it together. Open the authentication component file. Search for the login form. There's a comment above it that says login form. Inside it, we'll find a form similar to the registration form. There are 2 fields which are the email and password fields. We're going to validate both fields. We'll start with the email. First, we'll change the input element for the email to the vField component. This component will tell vValidate to validate the input whenever the value changes. We'll need to assign a unique ID to the field by adding the name attribute. We'll set it to email. Next, we'll add the rules. We can add rules directly to the field component. However, I think outsourcing the rules to an object will be beneficial for readability. First, we'll need to change the form element in the template to the vForm component. On this component, we can bind a property called validation schema to an object called login schema. A schema is an object that represents the fields in the form with the rules we'd like to enforce on them. This object doesn't exist. We'll need to create it in the data function. Let's do that now. Inside the object, we'll add the rules for the email field. The 2 rules we'll enforce are the required and email rules. We can work on handling the errors next. It's important to provide feedback to users who are trying to log in. Let's go back to the template. Below the field component, we'll add the error message component. The component should have the text red 600 class applied to it. This class will change the text color to red. We'll set the name property to email. The value for the name property should correspond to the value passed into the name property of the field component. We're finished working with the email field. Next, let's move on to the password field. It's the same as before. We'll change the input element to the field component to tell vValidate to perform validation on the value. Afterward, we'll set the name property to password. With that set, let's render the errors. We're going to copy and paste the error message component we used for the email input. The name property will be updated to password. The last thing we'll do is apply some rules to the password. Scroll down to the schema object we created for the login form. We'll add the password field to the object. We'll use the following rules: required, minimum, maximum. You'll notice I'm using the same rules we used in the registration form. There's not much of a reason for us to use completely different rules. We're not going to loop through the errors for the password because it's unnecessary to do so. The user will already know that their password is valid. We're finished validating the inputs. The next step is to enforce the validation in case the user attempts to submit the form without filling out the fields. We can do that by listening for the submit event on the vForm component for the login form. Back in the template, we'll listen for this event where the function to run will be called login. The submit event will do two things for us. Firstly, it'll enforce the validation before running the function we have in the expression. If the validation fails in any of the fields, it will not run the expression. Secondly, it'll prevent the page from refreshing when the form is submitted. We're using two form components in the authentication component. We don't have to worry about conflicts between the two. The form component will only validate field components passed into it. Errors in one component will not be reflected on the other. The login function doesn't exist. We'll need to define it. Scroll down to the methods object and define it. Inside the function, we're going to log the values parameter we'll receive from the event. This will help us verify that the function was executed if the validation was successful. We'll want to write more code, but let's make sure everything is working. Save your changes and switch to the browser. If I were to check the console, there won't be any errors. That's great. We shouldn't have any thus far. Next, let's try submitting the form with invalid values. This will break the rules because both fields are required. We will see the error messages appear below the inputs. Previously, we received false as an error message. However, we took the time to write generic error messages for our rules. The messages will work in all forms regardless of where we write the form in the application. After verifying the errors work, let's try submitting the form with valid values. After submitting the form, the console will output the values from the fields. Fantastic! We can move on to the next step, which is to render alert boxes with information about the form submission progress. Before we get to that, there is one change I want to make to the authentication component. If you look at the file in the editor, it's getting quite large. I think it would be a good idea to separate some of the logic into its own component. This separation of logic will make things easier to manage. Here's what we'll do. We'll create two components, one for the login form and another for the registration form. Inside the components directory, create two files called loginform.view and registerform.view. Then scaffold both files with the template and script blocks. I'm using Pascal casing for both file names. Vue recommends either using Pascal casing or Kebab casing. For this course, we're going to stick to using Pascal casing for our file names. The next step is to start moving the forms to their respective components. Starting with the login component, search for the login form in the template block of the authentication component. We're going to cut the vForm component completely. Paste it into the template block of the login form component. You may need to format it after pasting it in. Next, go to the register form in the authentication component file. Cut and paste the form component. We're going to grab the alert element too. We'll paste it into the register form component's template block. The templates have been transferred. They won't work until the data and methods are present. We'll move them next. Inside the authentication component, we're going to copy the data function. Since the authentication component doesn't need the data anymore, we're going to remove all the properties except the tabs property. Go over to the register component. We'll paste in the data function to the component's configuration object without the tabs property. Next, we'll create the methods objects. Then, we'll cut and paste the register function from the authentication component to the register component. The register component is ready. The login component still needs its data and methods. Switch to the login component file. In the exported object, define the data function and the methods object. The login component's data can be found inside the register component since we copied over the entire data object over to it. In the data function of the register component, search for the login schema object. This is the only data property we created for the login form. Cut and paste it into the data function for the login component. In the authentication component file, cut the login function. Paste it into the methods object of the login component. One last thing before we use the components. We should assign them names to make it easier to debug the application. In the login component, set the name property to login form. For the register component, set the name property to register form. That'll do it. The very last step is to register the components in the authentication component. We're going to register them locally because the forms won't be used anywhere else. They don't need to be global components. Inside the authentication component, at the top of the script block, we'll import the form components we created. I recommend prefixing them with the word app to prevent name collisions. Not required, but recommended. Inside the exported object, we'll create the components object. Register both components in the object. By registering the components, they're available in the template. We'll want to load the forms in their respective tabs. Scrolling up, we'll load the login form component under the tabs. Afterward, we'll load the register form component. The conditional directives will need to be added for toggling the forms. We're going to use the vIf directives instead of the vShow directive. They're going to be much more efficient. On the login form component, we're going to add the vIf directive. The condition will be the following: tab equals login. We'll apply the vElse directive on the register form component. Next, in the login and register components, we'll remove the vShow directives on the form components. That was a lot of refactoring to do, but well worth it. This refactor will make things easier to manage. I know I flew right through that. If any of the steps we took didn't make sense, I recommend reviewing any of the previous lectures for more information. Alright, let's quickly try testing the forms. In the browser, inspect the console for any errors. There shouldn't be any so far. After confirming there aren't errors in the console, try testing the login form with valid input. In the console, we will see the message logged from the login function. This is great. We were able to move the forms into separate components. None of the original functionality we had before was lost. We're not finished yet. The last thing we'll want to add is the alerts. The alerts inform the user about the status of their submission. We've already created the logic for this. We can copy a lot of the code we've already written with some modifications. Back in the editor, open the register form component file. In the data function, we're going to make a copy of the inSubmission, show alert, alert variant, and alert message properties. Then, we'll paste the data properties into the data function of the login component. We're making copies because the data properties will mainly be the same. However, the names don't make sense. We're going to change the word registration with login in each of the data property names. I'll recap what each property is for. The login inSubmission property will be used to disable the button while the form is submitting the data. It's to prevent excessive requests. The login show alert property will be used to toggle the alert's visibility. The alert variant property will change the color of the alert. Lastly, the alert message property will be the message inside the alert. The message property will need to be updated. Change it to the following. Please wait, we are logging you in. We can begin adding the alert to the template. Scroll to the top of the template block. We'll add the alert above the form component. Above the form component, add a div tag with the classes text, white, text, center, font, bold, P4, MB4. We'll add a v-if directive to toggle the element's visibility. The condition will be the login show alert data property. Next, we'll bind another class attribute to the login alert variant data property. Inside the element, add the expression login alert message. We'll need to disable the button while the form is submitting the request. You'll find the submit button at the bottom of the form element. Bind the disabled attribute to the expression login inSubmission. By default, this will be false. The button will remain enabled. We'll need to toggle the properties through the login function. Before we submit the request, we'll need to reset the data properties if the user is submitting the form again. We'll set the inSubmission and show alert properties to true. The alert variant data property will be set to bgblue500. We'll set the message property to its initial value. We'll cover submitting the request in the next section. In the meantime, we'll create a dummy response to let the user know their login was a success. Set the variant property to bggreen500. This value will change the alert box to the color green. Lastly, we'll update the message data property to the following. Success! You are now logged in. The process for validating the login form is the same as the registration form. This is the benefit of using the vValidate library. It makes the process very streamlined. Let's give things one last test. I recommend refreshing the browser for a fresh start. Try filling out the form with valid values. We will receive a success message. That's great. The button is disabled since we didn't toggle the inSubmission property back to false. We don't need to do that since the user has logged in successfully. We're finished. I know I breezed right through that. This was meant as an exercise to review everything we did. Both forms are properly validated. We can move on to the next step, which is to register the user and authenticate them. We'll cover that in the next section.